During this lesson, you will express numbers in correct scientific notation, convert from decimal to scientific notation and from scientific to decimal notation, and use conversion factors to perform 1- and 2-step metric conversions.
By now, you should have learned the fundamental physical quantities used to study objects and their motion, and the MKS units for these quantities. You should also know your metric facts about prefixes in the metric system. By now, you should have been quizzed on this information. In today's program, we will be working on 2 important math skills used in physics. First, we will be converting from one unit to another, and second, we will be reviewing scientific notation. Since the program is loaded with math, your local teacher will probably stop the tape after we finish reviewing scientific notation. That will give you a chance to practice and to take a quiz before we go on. While some of you may be very skillful in the use of scientific notation, others may not. So let's start there.
Here's a number that you should remember from chemistry. That's the number of atoms in a mole. It's called Avogadro's number, and it would be very difficult to write out every time you needed to use it in a calculation. Here's another one. It's the speed of light. You use this one a lot in physics. You may also use this one. It's the mass of one electron.
Sometimes the numbers we need to use are so big or so small that it takes a lot of zeros to write the number in decimal notation. That's when scientific notation comes in handy. You know what that sound means? In scientific notation, measurements are expressed in this form: m times 10 to the nth power. M is a number between 1 and 10. N is a power of 10. Because of this, scientific notation is often called exponential notation.
This number's in scientific notation, and you're probably familiar with scientific notation by this time in your high school career, but you may have learned one set of rules for putting a number into scientific notation, and then another completely different set of rules for taking it out. That can be confusing. You can forget. So what I want you to do is really understand what the power of 10 means. So when you see this, what does this 10 to the third tell you to do?
Multiply by 1,000?
That is correct, but we want to be even more general because this could be 10 to the 14th, and you don't know a number for that. So what if I said 2 to the third? What does that mean?
2 times 2 times 2.
That's right. You multiply by 2 3 times. So what does 10 to the third mean?
10 times 10 times 10.
That's right. So we take this 2.1 and we simply do what it says. We multiply it by 10 how many times?
3.
3 times. Good. And how do we multiply a number by 10?
You add zeros?
Not really, because the first time you multiply by 10, remember you're going from this side to this side, and so you'll really only add 2 zeros. So let's be a little bit more specific on this one. How do you multiply by 10 3 times?
Move the decimal.
And which direction?
Right.
To the right. Okay? So you'll move it to the right. All right, now what if I had negative 3 here?
1 over 10 to the third.
That's exactly right. You remember your math. So this is 1 over 10 to the third. And that's multiplied by 2.1. And so what does this really tell you to do?
Making the number smaller.
Making the number smaller, and you're going to divide by 10 how many times?
3 times.
3 times. And which way are you going to move the decimal?
To the left.
To the left to make the number smaller. Okay, good. Now, all this probably seems very obvious to you, but you'd be surprised how many students memorize their way through it, never really understand it, and then they forget, or they make silly mistakes. So I really want you to understand it. So let's practice doing one. Here we have 6.2 times 10 to the fourth. Susan, what does the 10 to the fourth tell you to do?
Multiply by 10 4 times.
4 times. So we're going to take our 6.2, and we're going to move this decimal to which direction?
To the right.
To the right. How many times?
4.
4. Good. 1, 2, 3, 4. This is where our decimal will wind up, and what do we put here to hold the decimal place?
Zeros.
Zeros. So we wind up with 62,000. Okay? One more. All right? Now we have 1.5 times 10 to the negative second power. What does that tell you to do?
Divide by 10 2 times.
Divide by 10 2 times. And for that, we'll move the decimal Which direction?
To the left.
To the left. 2 times. 1, 2. Put a 0 here to hold the decimal, and our answer is 0.015. Easy?
Yep.
Piece of cake.
What could be easier than that? Now you try some. Your teacher will stop the tape and give you a list of numbers to copy. Take the numbers out of scientific notation and express them in decimal notation.